Welcome to Old Iron Machine Works. In this video I will be getting the cover on the Monarch lathe. If you're new to the channel, a few months ago I picked up a 1955 Series 61 Monarch lathe that had some issues. I got it real cheap at an auction and it ended up having just a broken shifting fork. I've already done a video on repairing a shifting fork, and in this video I will be repairing a hole that somebody put in the top cover and getting the cover back on the lathe. I had to pull the spindle out in order to fix the shifting fork. So anyway, just making a little more progress. Here I'm showing a pump right there. That's the concentric that works the pump, and I'm just manually working the lever that actually works the pump. The pump's down underneath that gear. And what I'm doing, I ended up pulling the pump apart to check it out. Okay, it's got a little bit of scuffing, but nothing to be concerned about, I don't think, on one side. And the little check ball is seating very nicely. The body looks really good. Nice fit with the piston. So I think I'm just going to clean it up. Get some brake clean, kind of clean that out really good. But yeah, I see nothing wrong with the pump at all. I just think that oil was just way too thick for it to pull in. Alright, I got the pump back in. I took it apart just to check it out, and it was actually in really nice shape. But the gaskets were all messed up. Somebody had blue silicone. So anyway, cleaned it all off, make a couple new gaskets. But anyway, there's the pump. The pump's right here. It pumps oil up through this little line up here to this manifold up here, and then through this line, and then it comes over to the top, and then it feeds this manifold. When I mentioned the oil must have been too thick, I had the right type of oil, but it was a heavier oil, and I really wanted to use a little thicker, heavier oil. The problem is it was a little too thick, and the pump would not suck it through the filter, so I did have to get the thinner oil. Here I got my lathe hooked up to a life support system. Monarch did not do a very good job of designing the bottom of the headstock gearbox. It's very hard to flush and get stuff out. So what I got is a little pump here with a filter, and once I got solvent in the gearbox, bunch of particles, you can get it to float, but when you try to drain it, everything kind of sticks to gears and stuff. So what I ended up doing here with the solvent, I'm just kind of rinsing all the loose stuff down into the bottom, and then just taking a little stainless suction rod I have, and then when the stuff's floating around the bottom, then I could just suck it right up off the bottom, and then it pumps it, through the pump, through the filter, and then it just, pumps the clean solvent right back into the headstock. Here I could take the rod, and wherever I see anything floating around, I could just go in after it and suck it up. The thing about these, that little filter at the end of the pump is the only filter. The filter's for the pump, and the pump just basically lubricates 3 bearings. The rest is just splash, so any debris in there is just going to be slung around pretty much forever. Okay, here I got the correct weight oil, and as you can see, it's pumping very nice. When I had the heavier oil in it, it wouldn't. It would not pump a stream like that. It was just too heavy for the pump to pull through that filter. Here you can see the kind of boogered up glass. So my buddy that bought the donor lathe, he cleaned up one off the donor lathe for me, and then I'll put it in my lathe. It's pretty common to have metering valves get sludged up and not work anymore. So here I got all the lines off and just making sure that everything's flowing, through the metering valves and getting to where they need the oil. Okay, this line here pumps the oil to the sight glass. It pumps it over through this line and out right there. I had to enlarge the hole that tube went to, and all it does is just pump oil in, fills this up, and then drains back out. It pumps out this hole, fills this up, drains out that hole. Here's the cavity that it fills up, just a simple little sight glass. My buddy had the new sight glass all polished up, ready to go on, new gaskets and all. Thanks, Mike. Okay, I'm gonna manually work the pump. This normally, the cam lobe in here is what works this pump. It just raises it up and down. And I'm just gonna take a screwdriver and simulate it. And as you can see, it's pumping just fine. Back when I had to remove the spindle in order to do the fork repair, I had to saw my siphon gun out and just blasting and cleaning everything. And if I was on my A game, back then I would have ran the tap down through these cover holes and cleaned them all out, but I didn't. Therefore I had to cover it all with plastic. And then I ran the tap in there, and it was some brake cleaning in a vacuum, sucking out all the debris and little chips. Now my lathe came with a 700 RPM high range speed, and you could get different speed ranges. And the donor lathe that my buddy bought, it was 1,000 RPM. Series 60, which was basically the same, covered a lot of the parts are the same on a Series 60 61. And I called Monarch and asked him, what do I have to change in order to make mine 1,000 RPM? And I was kind of surprised. He says the only difference is you want to change the plate and you want to change the motor pulley. That is the only difference between the 700 RPM and 1,000 RPM. Is basically motor pulley and plate. So here I'm knocking my plate out, and then I'll clean up the 1,000 RPM one. It was a little bit rougher than mine, but I'll clean it up and rivet it back on, and away we go. Alright, here's the 1000 RPM tag, and you can see it's got a few more little battle scars on it. Um, but I just kind of ran a sander around it and cleaned it up somewhat. I'm just trying to make the lathe functional right now, and down the road, once I get it up and running, I would eventually like to clean it up and repaint tags and put a paint job on it. I kind of had some concerns that the rivet holes would be slightly off, but they weren't. They were perfect. So they clearly had a little jig for setting up and drilling the holes for the rivets. Okay, here's the cover off the donor lathe. Paint-wise, it pretty much matches mine. But if you look close, the seams are not very good. I could only get about half the bolt started, and the seams weren't even close. So clearly, they took a cover and a headstock and ground everything, you know, for a nice seam. Since the donor cover didn't fit very well, I decided I was just going to repair the lid that came with my lathe. Somebody put this big hole in it, and I'm not sure exactly what all it did, but I'm going to go ahead and keep the hole there and make a slug that'll go in the top to hold a bracket for a DRO. And here I'm just truing it up, and then I'll machine a little shelf there for the slug that'll go in it. Here I went to our old junk iron pile and found some old material that was for some drill rod tooling, and I needed to have something with a little extension that I can use for my ball turner. So this actually worked out perfect. I thought I would show the my ball turner. I bought this. Oh God, I'm 60 now. I think I was 26 or 27 years old. I bought a big old Monarch 22-inch swing from a shop my dad worked at, and with a lot of tooling. And this was one of the things that came with the lathe. But when I got it, it just had a beam coming straight down where you put your cutter, and I used it for years doming out some natural gas pistons, where I would just have the cutter, you know, do an inside dome. Probably about 10 years ago, I pulled it all out, had my dad flame cut
this piece and welded it up, you know, so I could turn it into a ball turner. And I think I've used it more as a ball turner. It is a little bit bulky, you know, heavy. You know, you gotta always use some kind of extension or whatever. If I didn't have something to get it out away from the chuck, as you can see, there's just not enough room. But anyway, it's worked good for many years.
Here, when I was trying to chisel that piece out, I couldn't even see what the seam was. Kind of boogered up a little bit. I wanted to take it out before I thought it was a nice solid chunk of steel. Thought I'd take a second here to talk about the bearings that I use for centering stuff. Gosh, probably this setup here, probably almost 20 years I've been using it. And what it is, there was a discussion on ARW Harold's group that they do on 1 o'clock on Sundays. And Dean Crawford over there at Arcade Shop was asking, or commenting that he had some water pump style bearings. This happens to be a 220, 230 water pump. And the impeller presses on the long end of the shaft right there. This is a Cummins water pump. Same thing. You got a pulley on one side and an impeller on the other. Here's just an idler, so they won't have shafts sticking out on both ends, just the one. But the shaft and everything is all part of the deal. And with this setup, you can just pick it up, flip it over, turn it however you want. And generally, the way I do it, you know, is you can see a valve in the chuck right now. Once I run it, I turn the lathe off, and then I just run it in to where it's running true. And then I always back the bearing off before it actually comes to a stop. Here I'm just machining a little area for an O-ring. I'll use an O-ring to make the seal. Here's my box from 20 years as a tractor field mechanic. It bailed me out many times. And just finding an O-ring that'll fit down in there and make a nice seal to the case, or the cover should I say. I had lots of ideas on how I wanted to anchor that slug in the cover, and I decided that I was just going to angle, bore, and tap for some 3/8 set screws. That was going to be more than adequate holding that slug down in that cover. Now, anytime you're trying to run a tap at an angle where it's coming out the side of the material, it's really critical to try to do some directional tapping, meaning putting pressure on the tap where it's always wanting to push in towards the material. Otherwise, it will naturally just want to just walk right out and blow out and screw up everything. Definitely patience goes a long ways with something like this. Now, the key to making this work is you have to have that little pocket in the bottom for the tip of the set screw to go into. If you don't, it'll just walk right out and bend the set screw, tear the upper part of the material, the slug away. But by having that pocket there to where that tip is controlled and can't blow out, is the keys to success with something like this. Now I just put the O-ring on, and the O-ring will make the main seal between the slug and the cover. I want to point out, I did not put the hole there. I just cleaned the existing hole up. They could not have picked the worst place to bore it, right at the intersection of all the gussets. If I would have did a hole, it would have been right between some of the gussets where it doesn't really affect the strength, but the cover's so crazy heavy anyway, I can't ever imagine there being a problem. Watching this video, I don't know why I didn't put some more Loctite on. It looks like I could have probably used a little more Loctite. By having those end of the set screws going into a pocket, it really is amazing how tight you can get them. Because even though you only got threads on half the side, if you look at the length of the threads, it's incredible how much force you can put on them. Here I'm just putting a couple stakes to keep the set screws. The Loctite is more than sufficient, but knowing the damage that could happen if one of those 3/8 set screws did ever come loose and get between a couple gears, yeah, it could ruin your day real quick. Here I'm going to make with some T material. I'm going to make a little lifter bracket for lifting the cover off. I know I could have just drilled another hole in the cover and put an eye-ring in it, but I just decided to just make a little quick little bracket. Okay, here we're ready to put the original cover back on after I pull off the donor cover off the headstock. The cover uses 3/8 Allen head bolts, and the clearance holes where the bolts drop down in were perfect size to just take a 7/16 fine thread tap and tap them out for the lifting bracket, and it actually worked out really nice. It's real common to see people just goop up with some gasket sealer the cover and slap it on. And I decided I wanted to make a nice gasket, and the gasket will be glued down to the cover itself with some adhesive, to where if I do want to lift the cover off, you know, I can take it back off and back on, hopefully without messing up the gasket. Once I tapped around with my little ball peen hammer and I had some nice marking, then I just went in with the scissors and, you know, finished cutting the gasket out with some nice pair of scissors. Here I'm making sure that I get the bolt screwed into the paper rather than just shoving the bolt down and then pushing the gasket away from the cover. Just kind of screw it right onto the hole in the paper. Here to me it's pretty obvious they had some kind of a bracket that the Chucky hung on by looking to wear mark here, and then right there on the top, you know, that was just years of something, you know, dangling around there, which I would just assume it was the Chucky. I had to kind of work over all the shifting levers and get them all lined up properly, and you know, the pockets for the set screws, had to back them out a little bit because they were binding and pinching. But anyway, I just thought I would talk a little bit about, you know, the shifting levers.
All right, these have a very unique shifting mechanism for changing speeds, and I just thought I would kind of go over it real briefly. First of all, I mentioned that the two pins here, they want this cover anchored. They don't want it moving around anywhere. These levers, as you can see, are doing nothing more than moving the main large levers. What they have a slight little, almost like a detent feel. About right there, there's a little resistance, and then it clicks over and stops. Same way with this. The outside ones rotate towards the outside, the inside ones rotate towards the inside. Towards the inside, towards the outside. Where they turn, all they're doing is pushing that this direction or this direction. And when they're camming over, let me try to make this so you can understand. When it cams over, it's pushing up against here. The detent you're feeling is nothing more than these rubber snubbers. And then it's pushing tight against the rubber snubber until it bottoms out here. The rubber snubber kind of locks it, you know, from vibrating and moving around. I will loosen these bolts up and rotate these, because where the levers hit, they have flat spots all the way around. So I'll just turn those a little bit to another new spot, and away we go.
I had all the shift levers already all backed together and Loctited in before I realized I didn't film it. But the problem is the set screw there, when you would tighten the set screw up, it would want to pull the shaft out and pull the handle in, because the position of the countersink for the set screw, and it would just pinch and not let the lever work, and they would just loosen the set screw up until it turned and call it good. I wanted the handle tight to the shaft, so I just got in there with the die grinder and then just moved the countersink and the shaft out a little bit, so the set screw would still lock up tight, you know, to handle the shaft, but not bind up. I appreciate you taking the time to check out the video. The next video for the lathe will be pulling the 10-horse motor out. I got to pull it out to change the wiring from 440 to 220. And I'll go ahead and change the bearings, and then I'll put the correct pulley for the 1000 RPM run. So that should be the next video. Once again, I appreciate you taking the time to check out my videos. I know this ship is called Pretty Keel, but if you got a good look at it, it was pretty rusted. The paint, I was thinking, all right, they should call this Old Iron Ship Company or something. Once again, thanks for watching, and if you like, give me a thumbs up, and if you're not a subscriber and you like this kind of content, hit the subscribe button.